Dear friends, now we will see the illustration number 3, that it is given that the magnetic field in a plane electromagnetic wave is given by By. So they have given the y component, it is given by By, that is 2 into 10 raised to minus 7 sine 0.5 into 10 raised to 3x. So 0.5 into 10 raised to 3x plus 1.5 into 10 raised to 11 t Tesla. Now it is asked that what is the wavelength and frequency of the wave. So first of all they have asked what is wavelength, what is frequency of the given wave. This is the question. And another question is asked, that is write an expression for the electric field. So they have also asked us the expression for electric field. So they have asked us different questions in this manner. So now first of all we will compare this equation, whether it is for E or it is for B. We compare it, that equation, with B. Here it is belongs to y, that means y component is there, it is in the y axis. We compare it with B0 sine kx plus omega t. So when we compare this equation with the above value, we get B0, that is 2 into 10 raised to minus 7 Tesla, then k, that is 2 pi upon lambda, is equals to 0.5 into 10 raised to 3, and omega, that is 2 pi f, is equals to 1.5 into 10 raised to 11. So here we are given different information. On the basis of this, first of all we will try to derive the equation of lambda. So if we put, we can have that lambda is equals to 2 pi upon 0.5 into 10 raised to 3. So ultimately this will come, that is 1.26 centimeter. In the same manner, if we want to find out the frequency f, we can say this is equals to 1.5 into 10 raised to 11 over 2 pi. That means this equation that will come to be 23.9 into 10 raised to 9 hertz. So that can be written as 23.9 or a 24 tentative. We can write it as 24 gigahertz. So this is the answer for lambda and frequency. Now it is clear that they have given that the original electromagnetic wave is moving on x-axis. Now how we can determine it? So for that we follow this equation, in which whatever component is indicated by the x, y or z, we can say that the resultant wave is moving on x axis. Here for this is moving on x axis. So obviously we have to bring out the equation, that new equation for the electric field will be how. So we know that if the resultant wave is on x axis, if magnetic field is given for a y axis, then we have the cross product E cross B, and that is, we have normal equation that we know, that is I, J and K. Here the resultant is indicated by I. B is given for y axis, this is for resultant axis. So how to get it? So resultant is actually indicated by negative x, because here in the equation they have given the plus sign between the two terms. So if it is given by a plus sign, we can say that it will follow the negative direction. So here we can say that we want ultimate the direction of the wave of electric field. So to get electric field, it is clear that it will be on a z axis with the equation that we can compare the equation of electric field, that can be given by Ez is equals to E0 sine kx plus omega t. So ultimately we need to find out this E0. We need to find out this E0, and that E0 can be obtained by using a simple term, that E0 over B0 is equals to C. So we can say that E0 is equals to C into B0, and therefore E0 is equals to 3 into 10 raised to 8 into B0 is given, that is 2 into 10 raised to minus 7, that we have already noted above, that we have already noted in above term. This is the given condition for B0. So it is obtained, and now we can put it here, and we can get the resultant value of E0, that is E0 is 60 volt meter inverse. So the equation can be represented as Ez is equals to 60, then all the terms remain as it is, that is sine. In place of k, again we can put the same thing, that is 0.5 into 10 raised to 3x plus omega, that is 1.5 into 10 raised to 11 t. The unit will be volt meter inverse. So that is up to the answer of the given question. So that is good, an IMP question. In question number 4 or illustration number 4, it is given that light with an energy flux. So energy flux is also called as intensity, and it is represented as power over area. So it is given that energy flux is given with the term that I, that is I is given for the question, it is given that they have provided the value I is equals to 18 watt per centimeter square. Now the equation of energy that can be written in the term of power, we can say that in term of power we can say total energy is equals to intensity into area into time. So here they have given us the energy is represented by suppose U. So in the question it is given that light with an energy flux 18 watt per centimeter square falls on non-reflecting surface at normal incidence if the surface has an area of 20 centimeter square. So we have given that area, that is 20 centimeter square, that can be written as 20 centimeter square, as I is also given in the term of centimeter. Then if area is 20 centimeter square, then find the average force exerted on the surface during the 30-minute time span. So they have also given us the time t, 30 minutes, that can be converted into seconds, that is 1800 seconds. So here we have different quantities and all the quantities are provided. So first of all we can find the energy. On the basis of that, first we can find out the momentum, and then momentum upon time is also considered as a force as per as 11th standard. So first we will derive the equation of U, that is equals to 18 into 20 into 1800. So that comes out to be 6.48 into 10 to the power 5 joule. So first we get the answer for energy. Now we know that momentum P is equals to U upon C, that is 6.48 into 10 raised to 5 upon 3 into 10 raised to 8. So we can have the momentum P is equals to 2.16 into 10 raised to minus 3. So it will be 2.16 into 10 raised to minus 3 kilogram into meter per second. So that will be the term for momentum. And in the last, that they want to find out the force force acting. So force is equals to momentum upon time. Here we have momentum 2.16 into 10 raised to minus 3. We have already given time, that is 1800 seconds. So if we put it, we get the answer that force is equals to 1.2 into 10 raised to minus 6 Newton. So this would be the force exerted by the light that incident on the given surface and we can calculate it with the help of the example. So that is very clear and given by a straightforward equation. Now the similar type of examples that are given in a textbook that we will see here, as we have already calculated the earlier question. In the same manner we can calculate the similar question, that is exercise example number 8, that is 8.8, in which we can get the information regarding this. So exercise example number 8.8 is now that we are taking into the consideration. It is given that suppose the electric field amplitude of an electromagnetic wave is E0, that is E0 is given, and that is given with the value 120 Newton per Coulomb, and it is frequency is 50 megahertz. So frequency is given, that is 50 megahertz, that is 10 to the power 6. So 50 into 10 raised to 6 hertz, that is given. So determine, we are asked to find out B0, then omega, then K and lambda. So all the quantities are to be find out. Find the expression for E and B also. So we have to find out the expression for E and B also. So now how to get this example? To get this example, first of all we will write the given information, that is B0 is equals to E0 over C, that we can write E0 is given 120 and C is very well known 3 into 10 raised to 8. So now this value will be 4 into 10 raised to minus 7 Tesla. So the first that we will get magnetic field as 4 into 10 raised to minus 7 Tesla for the term of B0. Now we can write omega is equals to 2 pi f. So here it will be 2 into 3.14 into 50 into 10 raised to 6. So omega would be what? So omega would be 3.14 into 10 raised to 8 radian per second. Now we also have derive an equation that we can write. We can use the equations of even 11th standard also, that is C is equals to omega over K, and therefore we can say that K is equals to omega over C. So now K is equals to 3.14 into 10 raised to 8, and C, that is 3 into 10 raised to 8. So K can be obtained, that is 1.05 meter inverse. So here we can get K also. Now we have also C equals to lambda f. So lambda is equals to C over f. C is 3 into 10 raised to 8. F is also 50 into 10 raised to 6. So ultimately lambda comes out to be 6 meter. So all these values that we have obtained, that they have asked, we have first find out b0, then we have obtained omega, then we have obtained k, then we have obtained lambda. Now we are asked to find out the expression of E0 and B0. So now, as the equation, it is given that find the expression for the E and B for the given condition. Here, if the wave is propagating along x-axis, that we can consider that suppose wave is moving in positive x-axis, it can be represented that for both the way, that is represented would be E0 sine kx minus omega t, but it would be on the y-axis. And in the same manner, if we write for the b, then we can say that b is equals to b0 sine kx minus omega t, but it would be in a k-axis, that is in z-axis. Here unit will be Newton per Coulomb. Here equation value will be Tesla. All the above values from the obtained equation, that we can put E0, B0, K, omega in these equations, and we can get the proper representation. Dear friends, now we will see the exercise example number 10. That is the last example of the exercise in a regular part. Exercise example number 10, it is given that in a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of 2 into 10 raised to 10 hertz. So we are given frequency, that is 2 into 10 raised to 10 hertz. So this is the frequency given. An amplitude, that is 48 volt per meter. So the electric field value is given, that is E0 is given 48 volt per meter. What is the wavelength of wave? So first of all, we are asked to find out wavelength. Then what is the amplitude of the oscillating magnetic field? So we are also asked to find out B0. Then show that average energy density of an electric field equals the average energy density of magnetic field. So that is third, that we have to show that average energy density, that is UE, is equals the energy density of B. So we have to show that or prove that. So first of all, we will go and find the basic values. That first lambda is asked. We can now say that C is equals to lambda F. So lambda is equals to C by F. We are having the value 3 into 10 raised to 8, and F is given 2 into 10 raised to 10. So lambda will be, that is 1.5 into 10 raised to minus 2 meter. That is the lambda. Then we are asked to find out B0. So here it is clear that B0 is equals to E0 over C, that is we are already having 48, 3 into 10 raised to 8, so this would be 16 into 10 raised to minus 8 Tesla. So that will be our magnetic field intensity. Now average energy density for electric field, we can say that UE is equals to, average is there, so it is written by 1 by 4 epsilon 0 into E0 square, as it is convertly and it is continuously changing with sinusoidal equation. Now UB is also written as 1 by 4 mu 0 into B0 square. Now we have to show that these both are equal, that we have to show over here. They have shown us that we have to prove that they both are equal. So now we will see that how it is possible and how it can be done. So first of all, what we will do, we will try to compare them. So we, from above equation, we will start with the equation of UE, that UE is given by 1 by 4 epsilon 0 E0 square. Now we know that E0 is equals to CB0. So we first put that, so we can say that UE is equals to 1 by 4 epsilon 0 as it is, and in place of E square we can say that C square into B0 square. Now we have also derived the equation, that is C square is equals to 1 upon mu 0 epsilon 0. So now if we put it, we can say that UE is equals to 1 by 4 epsilon 0. Now in place of C square we can put 1 over mu 0 epsilon 0 into B0 square. Now on the basis, in the same condition, we can cancel out these both E0, and if we simplify the equation, we get that UE is equals to 1 upon 4 mu 0 into B0 square. So this is the comparison for E0, but if we go above, we find that this equation is nothing but for the expression of B0 also, so it is in the term of magnetic field. So we can say that ultimately this is nothing but that is UB. So here we have compared and get the result that UE is equals to the UB, that is energy density is equal for both. Dear friends, now we will move to the illustration number 5 of the exercise, that is the next question, that is illustration number 5, that what are the given condition and what that we have to find out in the question. That is also one of the IMP question. It is given that calculate the electric and magnetic field produced by the radiation coming from 100 watt bulb. So here we are given the power of the bulb, that is 100 watt. at the distance 3 meter. So we are given distance r at 3 meter away. Assume that the efficiency of bulb is 2.5%. So efficiency is also 2.5%, and it is a point source. So now what we have to consider over here, we can consider simply we can draw a simple arrangement like this is bulb, and it will give a light, so it spread light in all the direction. Now we consider a particular range that is around it, that is 3 meter away from it, and we have to find out the effect it in this 3 meter distance away. So this distance is 3 meter away from it, and we have to find out the value of E0, B0 and field of E and B at this 3 meter away. Now first of all we can put here, that is I is equals to power over area. We can say power is given as 100, area is given by 4 pi r square. We are given r at 3 meter away, so if we put them, I can get the value, that is 100 upon 4 into 3.14, that is 3 square. And we are also given that the intensity whatever is there, that is having efficiency of 2.5. so here we also have to multiply it with its efficiency. So ultimately the intensity will come out to be, that is 0.022 watt per meter square. So that is the first, that is intensity. Now we can say that 1/2 of I, that is half of the intensity that can be considered as average. So that half of this intensity is provided by the electric field and half of it is given by the magnetic field. So first we will go for that electric field value, that is equals to 1/2 epsilon 0 E RMS square. So E RMS square into C. So that is the value that we have obtained. Already the given condition, we compare it, we can get 1/2 and I is already 0.022. Now when we compare these two equations, we will have the equation of E RMS, that we can say therefore E RMS square is equals to 0.022 epsilon 0 into C. So if we put all the values from these, we can have E RMS is equals to under root 0.022 over the value of epsilon, that is 8.85 into 10 raised to minus 12, and value of C is 3 into 10 raised to 8. Now when we simplify this term, we get the answer, that is 2.9 volt per meter. Now once as we obtain E RMS, we can have E0, that is root 2 into ERMS. We have already studied it in chapter number 7. So ultimately it will be 4.07 volt per meter. So here we have obtained E0. Now very common equation that we can get for the magnetic field, that we can say that E0 upon B0 is C, and therefore B0 is equals to E0 upon C, and that will be E0 we have obtained 4.07 upon 3 into 10 raised to minus 8 3 into 10 raised to plus 8. We get the answer, that is 1.4 into 10 raised to minus 8 Tesla. So this will be the answer for the question, and we can obtain the term in the magnetic field value. So these are the basic examples of chapter number 8.